All right. So we do start the class now. In the last class, we have discussed a definition of a network, a circuit, current, voltage, power, what you mean by series circuit, parallel circuit, then what is the meaning of open, closed, and short circuit. All these concepts are discussed in last two classes. Today we do discuss types of network elements. There are three types of elements. The first one is active element and passive elements, linear elements and non-linear elements, bilateral elements and unilateral elements. Elements are divided into three types. They are active and passive, linear and non-linear, bilateral and unilateral. We will see one by one. First, active element. We can call these two as elements. It is a battery. It is a bulb. In general, these two are called as an element. I hope you got the meaning of element here. Other than these two, can you give example for element? Can you give examples for element other than battery and bulb? Wire. Okay, it is also one of the example. Other than that, battery, bulb are here. Other than these two, what could be the examples for an element? Resistors, good. Any answers? Charge. No, it cannot be taken as a element. Capacitor is okay. Ammeter, voltmeter, good. Charge, it cannot be an element. Switch, good. Transformer, good. Adapter, yeah. Semiconductor, specifically like a diode, they are called as a semiconductor element. Transistor, good. I hope you got what you mean by an element, right? Right. That element is divided into three different types: active element and passive element, linear and non-linear, bilateral and unilateral. On what basis they have said it? Let us discuss it. I hope you got what meaning of an element, right? If yes, send me yes so that I can go further. Okay, all right. Next, what do you mean by an active element? I do read here. Active element delivers power to the other element which are present in the electric circuit. Sometimes they may absorb the power like passive elements. That means active elements have the capability of both delivering and absorbing the power. Okay, I do read it once again. Active elements deliver power to the other element which are present in an electric circuit. How many elements are present in this network other than wire? Can you send me an answer? It is voltage V. How many elements are there in this network other than wire? Can you send me an answer? 2 is wrong. Actually 2, but there are 3. 2 resistors, 1 voltage source, or in general, resistors and the voltage source. No, 1 is wrong answer. There are 3 elements. All right. So what is an active element here? It delivers power. It delivers power to the other elements in the network or in the circuit. So voltage source, it delivers the power, and that delivered power are absorbed by these two resistors. So that which is an active element in this circuit. Which is, I do repeat here, in this network, in this circuit, voltage source delivers the power, and that delivered power is absorbed by resistor R1 and R2. Keeping that statement in your mind, then can you say that which is an active element in this given network? Send me the answer in chat box. There are three elements. Out of these three, which is an active element? I have said the definition of an active element. Active element is an element which delivers power to the elements in the network. And I have said in this network, voltage is an element which is delivering the power. That delivered power is absorbed by these two resistors. Then the question is, which is an active element? Voltage source. Not only voltage, it should be an voltage source. Or else we can say that it has a battery. Am I clear? Have you understood the meaning of an active source? An active element? Okay. So, and also, sometimes it absorbs the power. That is also said here. Sometimes they may absorb the power like passive elements. So that means in most of the cases, active elements delivers the power. In very few cases, they do absorb the power. Okay. In general, they do observe and they deliver the power. All right. Next, we do see the definition of a passive element. Passive elements can't deliver power to the other elements. However, they can absorb the power. Okay. So we can see here, they can't deliver the power. Instead, they absorb the power. These two keywords are used to define the passive element. It can't deliver the power to the other elements, but they can absorb the power. That means that absorbed power is dissipated either in the form of heat or store energy in the form of magnetic field or electric field. I repeat. So passive elements, they can't deliver the power to the other elements. However, they can absorb the power. That means these elements either dissipate the power in the form of heat. First option, they do deliver, either they do absorb the power, and that absorbed power is dissipated in the form of heat, or it is stored in the form of energy. That energy either magnetic field or electric field. I hope you have understood the meaning of a passive element. All right. So in this figure, then can you observe which is an active element and which is the passive element? Example for active elements: voltage source, current source. Examples for the passive element: resistors, inductors, and capacitors. Not only these, there are many. So you will come to know in the next slide. Then consider this figure. Then identify which is an active and passive element here. So this is an active element. Bulb is a passive element. Battery is an active element. All right. I hope you have understood the meaning of active and passive element properly. Have you understood the meaning of active and passive elements? Good. We go ahead. So there are other than those examples, we can find examples for active elements: battery, generator, transistors, tunnel diode, triode valve. Then how do you say that transistor is an active element? Because it has a capability of amplification. For that reason, then active transistor is known as an active element. Then passive elements, examples: resistors, capacitor, inductor, diode, and transformer. Next we do go linear element and non-linear element. First, we do say the definition of a linear element. Linear elements are elements that show a linear relationship between voltage and the current. In general, linearity should follow two principles. The first one is homogeneity. What do you mean by homogeneity? I do say here, let us explain the meaning of homogeneity using a figure here. You can observe here this is the first signal and this is the second signal. What is the difference between these two? Original input having an amplitude. For the same input, we have multiplied number 2 and it is increased. Similarly, here it is an input signal. For this signal, we have multiplied number 2 so that it is happening here. So consider an system here. Consider the system. For that system, a signal x of t is provided. As a result, y of t is produced. For the same system, the input signal is multiplied with an value a. Then output should be a times the input signal. So that if this is the case, then that system is called as a homogeneous system. That is happening here. So we can say, consider a graph. Consider a graph here. Here it is 1, here it is 1. For linear increasing value of x, then there is a corresponding increase of y. We can observe at any point of value. It is a homogeneous. Now, if you want to say that the element is a linear, along with the homogeneity, it should follow the additivity. What is the meaning of this? So consider a system. For this system, x1 of t is given. As a result, y1 of t is the result. And for that system, x2 is provided. As a result of x2, y2 is given. Y2 is the result. Then if input is the sum of x1 and x2, then output must be y1 of and y2 of t. If this is a case, means then we can say that the system is additive in nature. So if you want to say that the system is linear, then it should be homogeneous and it should follow the additivity. I hope I'm clear with the concept. So we can observe here. You can observe input 1, input 2. If these two are added, then this is the result. Input 1, input 2, these two are added and this is the result. Okay. So in general, if you want to say there are two inputs, x1 of t, because of this y1 of t is providing, x2 of t is the input, because of this y2 of 2 is coming. If these two are added, output should be added result. This is what additivity. If these two elements are scaled by an value a and b, the same thing should happen in the output also. Same thing should happen in the output also. So this is what A and B. If this is the case, means the given element is linear in nature. All right. Examples for linear elements: transistors, inductors, and capacitors. Now, what do you mean by non-linear elements? These are those that do not show a linear relationship between voltage and current. Examples: voltage source and the current source. I hope you have understood linear and non-linear element. If yes means I'll go ahead. Repeat. Okay. If you want to say the given element is linear, if you want to say the given element is linear, it should follow two operations. The first one is homogeneity and additivity. What do you mean by homogeneity? For any change in the input, a corresponding output should change. If input is 2, output should be 2. If input is 100, output should be 100. So if there is any change in the input, that should reflect in its output. That is called as a homogeneity. All right. Then what do you mean by additivity? For the system, if input 1 is providing an output 1, input 2 is providing an output 2, if these two are given simultaneously, output should be added result of inputs. So if it is followed, then systems are called as a elements are called as a linear elements. Am I clear? Okay, there are many examples are there in upcoming slides. If you do have still doubts, then those doubts will be cleared in upcoming slides. I'm damn sure. First, you should think that linear element are the element, they do follow homogeneity and additivity. Homogeneity means if there is any change in the input, then output should be same, and it should start in a origin, that only that condition will apply. Then additivity, for if n number of inputs are added, then result should be added result of input signals. All right. Next, we do go for what do you mean by a bilateral and unilateral signal. Bilateral and unilateral elements. Bilateral elements are the elements that allow the current in both the directions and offer the same impedance in either directions of the current flow. So, bilateral elements, they do allow the flow of the current in both the directions. Consider here the figure. Consider the figure here. It is an element Z, so that it is providing an impedance Z value between the nodes A and B, and the current I is flowing from A to B. Because of the flow of the current I, then voltage V is generated, produced across an element Z. Have you understood the meaning of this figure? Bilateral elements are elements that allow the current in both the directions and offer the same impedance in either directions of the current flow. Okay, consider an element. It offers an impedance Z between the node A and B. Current is flowing from node A to node B. Because of this current I, then voltage V is developed across it. Okay, so if this element is allowing the current from A to B and B to A by keeping same impedance in both of the cases, then such elements are called as a bilateral elements. Okay, now examples for bilateral elements are resistors, inductors, and capacitors. Then let us explain this figure. The current I is flowing from terminals A to B through the passive element having an impedance of Z. What is Z? Using Ohm's law. What is Ohm's law? V is equals to I into R. What is R here?
I.
V divided by I. Okay. So R can also be written as a Z. You will come to know what is the difference between R and Z. It is called as a resistance. It is called as an impedance. In future, you will come to know the differences between resistor and the impedance. So what is an current here? So what is a resistor or impedance? It is the ratio of voltage across that element between the terminal A and B and the current I, that is said here. Okay. Next, the second case, the current I is flowing from the terminal B to A, although the passive element having the impedance of Z, same impedance is there, and current is flowing from A to B. Current is flowing from A to B, then voltage is developed in this fashion. When current is flowing from B to A, this will be the direction. This will be the direction. At that time, obviously, these two currents are opposite in direction. If we do take this as an I, then obviously it is minus I. All right. And if you take this voltage drop as a positive voltage, then you can observe here, in the place of plus it is minus, in the place of minus it is positive. Then obviously it is what? A negative voltage. So, but what is impedance? Impedance Z is equals to V by I in the first case. In the second case, it is minus V divided by minus I. That is equals to again V by I. So what is conclusion here? If an element is providing a positive impedance, then such elements are called as a bilateral elements. All right. Then what do you mean by a unilateral element? Unilateral elements are those that allow the current only in one direction. Hence, they offer different impedances in both the directions. All right. Then we have discussed what you mean by active and passive. Next, linear and non-linear, and unilateral and bilateral elements. Here the VI characteristics of one element is given. Based on this graph, then you should identify or verify whether that element is linear or non-linear. Whether that element is linear or non-linear, verify that element as active or passive, verify that element as a bilateral or unilateral. It is a VI characteristics of any one of the element. Based on this graph, identify whether it is linear or non-linear, active or passive, bilateral or unilateral. Okay. First, we do verify the first one. From the above VI characteristics of the network, element is straight line passing through the origin. Hence, it is a linear element. Then, is it obeying? Is it obeying a superposition, means additivity and homogeneity? Yes, it is obeying. For any change in its input, there is a corresponding change in its output. For any change in its input, corresponding change in output. Okay, you can take any value. Then there is a linear change is observed for any value of change in its input. For that reason, we can say that this element is linear. All right. Verify the element is active as passive. Okay. This system is in the first quadrant. So we can call this as a first quadrant, second quadrant, third quadrant, and fourth quadrant. We can observe the characteristics of that element lies in the first and third quadrant, right? Okay. In the first quadrant, The values of voltage and currents are positive. I is positive here. This scale is having positive values. This scale is having positive value. Multiplication of these two gives a positive value. All right. In the third quadrant, the current is negative, voltage is also negative. Multiplication of these two gives a positive value. Because of this, the VI characteristics offer a positive impedance value. The network element is a passive element. Okay. So the conclusion is, if you want to say the given element is passive in nature, then its VI characteristic curve should fall either in first quadrant or in third quadrant. All right. Next, say that whether it is bilateral or unilateral element. For every point VI on the characteristics, there exists a corresponding point minus V minus I on the given characteristics. Hence, the network is bilateral element. Graph is given. Based on this graph, can you say that the given element is a passive? How to identify the given element as a passive? You should calculate its impedance. If impedance is positive, then that element is a passive. What is impedance here? Impedance equals to a ratio of voltage divided by a current. And in this graph, we do find four quadrants: 1, 2, 3, and a fourth quadrant. V and I, they are positive in first quadrant, so that a ratio of those two gives a positive value of impedance, so that the elements whose VI characteristics lies in the first quadrant is a passive element here. And also, the VI characteristics of any element, if it lies in the third quadrant, voltage and current are negative, ratio of voltage and current is positive, so that impedances in the third quadrant is positive. So conclusion is, VI characteristics of an element, if it lies in first and third quadrant, then such element is a passive here. Linear, if it is following additivity and homogeneity, then we can say that the element is linear. It is passing through origin. Also, we can find a proper relationship between input current and output voltage. Based on this graph, we can predict any value, so that for any change in a current, a respective change in the voltage is occurring, so that it is linear. How to identify the given element is bilateral or unilateral? Take any point. It is what V and I. Okay. I and V, X quadrant first, Y quadrant next. Its corresponding negative values are minus V and minus I and minus V. If it is existed symmetrically on the VI curve, I and V, let us take this as a point, corresponding its negative values minus I and minus V, if it lies in the VI characteristics symmetrically, then we can say that that element is a bilateral. So that based on this graph, we can say that the given element is passive, linear, and bilateral. Consider the next example. VI characteristics lies in first quadrant as well as second quadrant. In the first quadrant, impedance is positive because V is positive, I is positive, ratio of those two is positive. VI characteristics lies in second quadrant as well. In second quadrant, V is positive, but I is negative. As a result, impedance is a negative here. So that it cannot be a passive element, so that it is an active element. It is said that it is non-linear because we don't find any a proper relationship between input and the output signal here. You can see here. You can say at the origin, when input is 0, output is 0. Okay. Assume that when input is 1, again the output is 0. When input is 2, suddenly we have observed a change in its output value. When input is 1, output is 0. When input is 2, we have observed some drastic change in its output. So that we don't find any proper relationship between input and the output here. So that it is a non-linear. It is said that it is unilateral. It is said it is unilateral. Yes, take any value, take any point. It is I and V, I and V. Corresponding minus I and minus V, we don't find a symmetric value. So that it is a unilateral. Consider the third graph of VI characteristics lies in first and fourth quadrant. In first quadrant, impedance is positive. In fourth quadrant, impedance is negative because I is positive here, but V is negative. See here, it is minus V and it is plus I. So that minus V divided by plus I, that gives negative value of an impedance. So that we can say that it is not a passive device, so that it is active. Even though it is passing through an origin, even though it is passing through an origin, we don't find any proper relationship between input and output signal. When it is 1, here 1. When it is 2, here it is 2. There is no linear relationship between the input and output. Instead, we do find an exponential relation, so that it is a non-linear. And we don't find any mirror image of and values of current and the voltage. Consider any point. At this point, its mirror image will lies in a third quadrant, so that we don't find any mirror image of the values, so that it is a unilateral. Consider the fourth example. The VI characteristics lies in first and third quadrant. Impedance value in first quadrant will be positive. In the third quadrant, it is positive, so that it is passive. And this device is linear only till this point. The device is linear only till this point. Afterwards, if a further increase in the current, there is no change in its voltage because it is constant here. Further increase in the current, we are not finding any increase in the voltage. For that reason, it is linear only till this point. Once this point is crossed, then it shows a non-linear property. So that as a result, it is a non-linear. And also it is unilateral because we don't find any symmetric or mirror image of the values, so that it is a unilateral signal. Next, we do find next example. So VI characteristics lies in the second quadrant. So impedance is negative, so that it is active. It is non-linear and it is unilateral. I hope you have understood our fifth graph. Okay. So in the sixth graph, it is passive because it lies in the first quadrant and the third quadrant. So that impedance Z, it is the ratio of V by I. It is positive in first and third quadrant, so that it is passive. It is non-linear and it is unilateral. Because it is non-linear, because we don't find any proper relationship between input and output. We don't find any symmetric values or mirror image of the VI characteristics, so that it is a non-linear, unilateral and passive. Again, first and second quadrant, in second quadrant impedance is negative, so that it is active. There is no proper relationship between an input and output signal, so that non-linear, and we don't find any mirror image on the VI characteristics, so that it is a unilateral. It is passive because VI characteristics lies in a first and third quadrant. Non-linear because we can find a zigzag curve. Unilateral because there is no any symmetry. Again, it is a passive because lies in first and third quadrant. Non-linear because of there is no proper relationship between input and output signal. It is bilateral because we do find a mirror image on the VI characteristic. You can see here. What is mirror image of this one? At this point, I and V corresponding negative values are these minus I and minus V. We do find here, so that these two are symmetry. You can take any value here and you do find a proper value, and if you find here, we will get a symmetric value, so that it is a passive, non-linear and bilateral. Do you have any doubt on these